In this video, I'm going to solve some absolute value inequalities. So remember that last day we learned that the absolute value of A is equal to A if A is greater than or equal to 0 and minus A if A is less than 0. We also derived the following two facts that assist us when we're solving absolute value inequalities. The first is that the absolute value of x is less than a if and only if minus a is less than x is less than a, and the absolute value of x is greater than a if and only if x is greater than a or x is less than minus a. With these facts in mind, let's solve this inequality. So the inequality is absolute value of 2x minus 3 greater than 5. So we want to use the following fact, the fact up here, that the absolute value of x is greater than a if and only if x is greater than a or x is less than minus a. So in this situation, that translates to 2x minus 3 is greater than 5 or 2x minus 3 is less than minus 5. Those are the two inequalities that we want to solve. So for the first one, we get 2x is greater than 8, or x is greater than 8 divided by 2, which is 4. So that's the first inequality. And the second one, we get 2x is less than minus 2, or x is less than minus 1. Okay? So for our solution, we have x is greater than 4 or x is less than minus 1. And writing that in interval notation, the solution set is minus infinity to minus 1 union 4 to infinity. Next, let's solve this absolute value inequality. So here we have 1 is less than, absolute value of x minus 5 is less than 2. And this doesn't fall into either of those two categories that we discussed earlier. So what we're going to do in this case is we're going to rewrite the absolute value using the definition. So the absolute value of x minus 5 is equal to x minus 5 if x minus 5 is greater than or equal to 0, or if x is greater than or equal to 5, and it's minus x minus 5 if x minus 5 is less than 0, or if x is less than 5. So that means we have two cases. The first case is where x, case 1, that's where x is greater than or equal to 5. So in this case, the inequality in question is 1 less than x minus 5 less than 2. That's because x is bigger than or equal to 5. And so what that then means is that the absolute value of x minus 5 is positive x minus 5. So we sub that in. Our second case is when x is less than 5. And in this case, the absolute value of x minus 5 is equal to negative x minus 5. So in that case, our inequality becomes 1 less than negative x minus 5 less than 2. And now we go ahead and solve. And we get, adding 5 to all parts of the inequality, we get 6 less than x less than 7 in the first case. In the second case, let's pull that negative through, so I have 1 less than negative x plus 5 less than 2. Let's subtract 5 from all parts of the equation to get negative 4 less than negative x less than negative 3. And now I'm going to divide or multiply by negative 1, which gives me 4 greater than x greater than 3. Because I just divided by a negative, I had to flip the inequality sign, which of course should be written as 3 less than x less than 4. So what that means is that the original inequality has any value between 6 and 7 or between 3 and 4 is a solution to the original inequality. So our solution set looks like this. 3, 4, the interval 3, 4, union, the interval 6, 7.